Now we're going to talk about how to find electron configuration using our shortcut. So the shortcut is called the noble gas configuration, and basically what it is we use the noble gases as a placeholder for a certain amount of the electron configuration. So if we're looking at our example down here for chlorine's electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5. But the shortcut allows us to cut out this portion of it, the 1s2, 2s2, 2p6, and replace it with the noble gas. And that reason is because that noble gas has the same electron configuration as this portion. So the electron configuration for neon is 1s2, 2s2, 2p6. And so writing the electron configuration with the noble gas allows us to use that noble gas as a placeholder so we don't have to write as much. And then what comes after this portion are the valence electrons. And so the noble gas is basically everything that's on the inside, and then what's left over is what's in the last row, what's in the last ring. And so I'm going to show you how to find your noble gas configuration. So let's do nitrogen. And so the normal electron configuration for nitrogen is 1s2, because we have to start up here and we go through the s, and then 2s2 because we have to go down to our next row, and then 2p3 because we end up in the p sublevel, and nitrogen is the third one over. And so we know what our regular electron configuration for nitrogen is going to be. And so with the shortcut, we first need to find our element. So nitrogen's right there. Our second step is to find a noble gas that comes before it. So this column right here, those are our noble gases: helium, neon, argon, krypton, xenon, radon. And so what that means when I say find the noble gas before, you're just going to go to your noble gas column, and then you're going to go up one. So the noble gas that comes before nitrogen is helium. Once you have that noble gas, you are going to write it in brackets, like I did. Once you write the noble gas, we can then start the next row. So we can start the row that nitrogen is in, which is in row 2. And so starting at row 2, we have our second row. We're starting in the S sublevel, so you're going to write S, and we have to go through 1, 2 elements in the S sublevel, so we're going to write 2 as our exponent. We're still in row 2. Now we're in the P sublevel, so you're going to write P, and then nitrogen is 1, 2, 3 over. And so the final noble gas configuration for nitrogen is helium in brackets, and then 2s2, 2p3. Let's try a different one. Let's try germanium, Ge. So we know where germanium is because I'm circling it. So what we need to do is go find the noble gas that comes before it. So let's go to our noble gas column and then up 1. And that is argon. So we're going to write AR in brackets. And so our next step after we do that is to come down to the next row, which is the one germanium's on, and our new starting place is at the beginning of that row. So we write 4 because we're on row 4. We first have to go through the S sublevel, and then we go through 1, 2 elements. So you're going to write 2 as your exponent. Our next thing that we're going to write is 3D, because remember, our D block is 1 row number behind. So instead of writing 4D, we'll write 3D. And we have to go through 1, 2, 3, 4, 10 elements to get to our next section, which is P. So you're going to write 10 as an exponent. And then we are back at 4. Now we're in section P, and germanium is 1, 2 over, and so you're going to write 2 as your exponent. And so this is the noble gas configuration for germanium. So again, to find the noble gas configuration, you need to find your element, and then you need to go over to the noble gas column and then up 1 to find the noble gas you're going to be writing. Once you write that in brackets, you're going to start on the next row, and that is the row that your element is on. You're going to start at the very beginning and then write the electron configuration starting at that point to your element. And this makes sense because this little bracket in the AR tells us that the electron configuration is complete up until argon. And so we know argon's electron configuration, and so we can just put that in brackets and then write the rest of our electron configuration.